Okay, again, good morning, everyone. So I already started the recording. I hope you had a good weekend, though I know yesterday you were already back on ACAD mode because you had your computation classes. It's just that yesterday, around midday, we found out that there's a presidential memo saying that apparently government work will be cut at 3:30 p.m. yesterday to let government employees observe Family Week or something. So that's why I don't know if it's on this lecture section or the other one. There are some lab classes that were affected because their schedule is 4 to 7 p.m. Some of their instructors decided to meet the classes kasi technically hindi naman covered yung students. Kaming mga government employees yung covered. So some of them decided to push through with the with the laboratory class. Others decided to observe the memo. So I hope for those who were not able to meet yesterday, your lab instructors will provide a video recording. Yun na lang yung request ko sa kanila about the principle of reduction ad absurdum or the proof by contradiction for propositional statements. So hindi pa naman natin siya kailangan today. Probably we'll need that on Thursday, or if not next week pa. So you'll still have time to catch up. And anyway, you already have those materials in module number in the lecture in the work text. You can find appropriate pages in the study guide for week 2. So makikita nyo na siya doon. So I think it's just 1 or 2 pages. So pwede nyo siyang basahin. And gusto ko lang talaga na merong at least may verbal discussion with your lab instructors para mas madali niyong maintindihan yung nasusulat dun sa work text, okay? So, but again, you still have times to watch the videos or to read the materials on the work text, okay? So I wanted to do that so that this week will be focused on the content of study guide for week 3, which is about predicate calculus. So here, so last time, start na tayo mag-prove ng validity or invalidity, but they all sort of deal with generic propositions, meaning propositions that work for all cases. Like when we say, I think we have as an example, all fish are mammals. So we are referring to the class of all fishes and the class of all mammals. Those are the classes that are involved in a proposition. But sometimes in logic or even in mathematics, we might want to qualify our statements and not to generalize the entire members of a class. And for that, we need a different type of calculus for logical propositions that have limited scope. And that's what we'll be talking about this week. We'll be talking about predicate calculus, which are basically propositions but with specified classes involved. So hindi yung buong class yung kasama dun sa propositions or dun sa claims ng propositions, but it might be a certain subset of that class. Okay. So what are the things we need to look out for? So at the end of the week, here are the expectations from you guys. First, you should be able to determine the truth value of propositions that involve one or more quantifiers. Second is to translate quantified statements into symbols, and this is important because usually halos mechanical naman yung mga ginagawa natin. Pero the problem is once we encounter an informal statement or an statement, sometimes it's hard for us to start doing the math. And usually that's the one thing that I see in a calculus. They really know how to compute things, but the problem is how to translate real world problems or English problems into mathematical problems. Because what I observe, magaling sila dun sa pagkakompute ng integrals, pagkakompute ng derivatives. The problem lies on pag binigyan mo na word problem. So, siya yung posible step. And we also have that here in logic. So kahit sa Math 101 meron, actually bread and butter natin yung mathematicians. We have word statements or layman statements and we want to prove it. And usually the tools that we learn are all catered to symbolic statements. So that's why objective number 2 is very important, not only for the purpose of or for this week, but also for, I think, your career as mathematicians or teachers in the future. And then the third objective is quite related to the second one. We want to translate informal statements into formal statements and vice versa. And number 4, provide correct negation of quantified statements. So if you're following the study guide, so I think the week is divided into 2 or 3 topics. Pero I highlighted here the salient points of our discussions. We'll talk about what are the different forms of quantifiers and how do we determine the truth value of a proposition with quantifiers. And then we'll try to translate informal mathematical statements into formal ones. And then how do we properly negate statements involving quantifiers? Perhaps we'll do this on Thursday. Okay. May isa pa palang topic. Yeah, topic number 4. How do we determine the truth value of statements with more than one quantifier? How do we negate a statement with multiple quantifiers? And how do we translate informal mathematical statements with multiple quantifiers into formal ones? So we'll be covering pages 25 to 36 of the work text part 1. And then, of course, at the end of the study guide, you'll have here worksheet number 3, which is due on October 4. I saw a couple of you submitted already worksheet number 3, so kudos to you guys. But for the others, yeah, you still have 1 week. Deadline is on Monday. You also have your laboratory classes on Monday. Para kung may tanong kayo, pwede nyo tanungin yung mga lab instructors nyo. And they can definitely help you with worksheet number 3. Okay. So, nahuli pala yung good morning greeting dyan. So, for today, what we'll be talking about would be covered or is under what we call predicate calculus. So, predicate calculus is the part of logic that deals with the inner structure of propositions. So, kasi ang ginawa lang natin dati is propositional calculus, meaning how do we work with propositions in general. But now we will be looking at the structure of propositions because napakasimple ng mga propositions sa kinonsider natin last time. But don't get me wrong, we will be still using those things that you learned before. So huwag niyong kakalimutan paano nagpo-prove ng invalidity, ano yung truth values ng compound propositions, and so on. We'll just be adding additional layer to it. We'll just be digging deeper into the structure of those propositions, okay? And now we'll be considering propositions which have 3 parts to it, okay? So kasi dati isang part lang, meron kang statement, convert natin into a variable or into a letter A, for instance. So nalalaman natin, meron lang 2 posibleng truth value yung proposition yan, true or false. Pero now, if we dig deeper at tinignan natin yung mga propositions, pwede pa pala nating further classify sila into, say, universal and existential propositions. So for us to dig deeper, kailangan nating tingnan yung 3 parts ng mga propositions. So the first part is called a term, which is what you can think of as the subject of a proposition. So ito yung mga members ng classes under consideration that we are trying to describe. So kumbaga sa sentence, siya yung subject. Siya yung simuno nung pangungusap. So usually, the subject, the one we want to talk about or the one that we want to describe, is denoted by small letters like variables, your usual variables X, Y, Z, sometimes by A, B, C also. So yun yung parang identifying characters nila. Perhaps you will see this later in more details. And then the second part is what we call a predicate. So parang sa sentence lang, ito naman yung, kung sa sentence, yung predicate, siya yung nagde-describe dun sa subject, o siya yung panag-uri, kung naalala niyo yung Filipino. Pero the idea here is the predicate tries to describe the term or the subject of the proposition. Okay, so basically this is a sentence in logic. So in logic, it is a sentence that contains a finite number of variables and this is a propositional statement. So there is a claim here of something about the term or the terms in the proposition. So yung predicate, siya yung nagde-describe or siya yung claim of something about the terms being discussed. Or usually we denote it by P. So when we write P of X and we say P is a predicate, that means we are saying that statement P is true for the term X or for the subject X. So usually, ito yung usual propositions na nakita natin from last time. Ang kaibahan niya lang, there is a certain term being for which the proposition is being claimed for. Okay? And the permissible values of X are called, or the set of permissible values of X are called the domain of a predicate variable. So si P yung predicate, siya yung predicate ng proposition. Tapos si X, siya yung predicate variable. Lahat ng pwedeng i-substitute kay X, ang tawag natin sa kanila ay mga elements o members ng domain ng predicate variable. Okay? So again, P of X can be read as statement P is true for the subject X. And that statement P of X is what we call the predicate. So parang siya yung buong sentence. Kung sa sentence structure sa English, yung predicate ay isa lamang part ng sentence. Sa logic, yung predicate siya na yung mismong sentence. Okay? Which contains also the term or the subject. Okay? Now, a predicate can involve a number of variables. So it can be more than one. For instance, you have here. So P of X1, X2, until Xn merely stands for statement P is true for X1, X2, until Xn, where the exabytes are members of domains for each of the statements involved in the predicate. So elements sila ng domain A1 cross A2 cross AN. Kasi ordered the n tuples sila. Okay. Now, yeah, don't worry if this sounds very abstract. We will be looking at specific examples later. Oh, ito na pala, illustration 1. So ito yung mga example ng mga predicates. So for instance, look at example A. P of X stands for X being a mathematician. So X is a mathematician is a one place or a one subject predicate. Okay? Yung subject ay X, yung predicate yung buong sentence. X is a mathematician. And usually, if we want to symbolize this later, we can say let P of X be the statement that X is a mathematician. So in our work, we will just be dealing with this statement as the variable P of X. Okay. And then to illustrate the case of multiple variable or multivariate predicates, look at example B. For example B, we will let X, Y, and Z be integers, and we will let P of X, Y, Z be the statement that X plus Y plus Z equals 5. So this is an example of a three-place predicate because we have three subjects in it. The subjects or the terms are X, Y, and Z, represented by those variables. Those variables, or the domain of those variables, would be the set of integers. Or if you want to be more technical about it, ang domain niya ay Z cross Z cross Z. Because here the ordering of X, Y, and Z is important. So nagmamatter sino yung i-assign mo sa X, sino yung i-assign mo sa Y, sino yung i-assign mo sa Z. So hindi, you can think of predicates to be non-commutative statements. Hindi mo pwedeng basta-basta pagbali-baliktaran. There are cases where that will work, but you need to be careful about it because that will not happen for all propositions. Okay. So yeah, I think that's it. Those are examples of predicates. And then if you look at example A again, ano yung domain? Ano yung mga posibleng ipalit natin sa variable X? Can somebody tell me what could be a nice domain for the first predicate or the first proposition? So when we say domain, ano lang yung mga posibleng values ng X? Ano yung pwede kong i-substitute para kay X? Kunwari, wala pa yung example dyan. Anyone?
Leibniz, sir.
Come again, sorry.
Leibniz.
Okay, yeah, that's a possible value for x. You can replace x by Leibniz. That's great. You can also replace x by René Descartes, as the word text suggests. Or in the future, you can replace it by your name, right? So meaning, ano yung mga posibleng values ni x? So you can say the domain would be the set of all persons, okay? Or the set of all mathematicians, if you want the statement to be true. Yeah. Okay. Yeah, thank you, Charles. But you just need to be a little bit careful about it. Thank you, Justin. Justin said set of all scientists. Okay, those are possible answers for the domain. But remember, the domain could be more generic. It could be more general than all of those your suggestions. Because yung domain lang naman ay set ng lahat ng pwede kong i-substitute. It doesn't matter if the statement will be true or false. Yun yung kaibahan sa logic. So, pag sinabing domain ng isang predicate, lahat ng posibleng ipang substitute. And we are not saying na lahat ng pwedeng i-substitute such that the statement will be true. The statement can be false, and that's one of the purview of logic to check what's the truth value of a predicated proposition. Okay, pero yeah, you can be more generic and say the domain for number one is the set of all persons, okay, or the set of all people living or dead. So you can think of that. But of course, if you want to have a limited scope, you can say, yeah, as Charles suggested, set of all mathematicians, or as Justin said, set of all scientists. Even yung suggestion ni Victor kanina na set containing Leibniz, that's a possible domain if you are restricting your universe. Pero again, in math, we usually want a more generic possible values for our variables, okay? Okay, now medyo I think mas clear yung domain dun sa second statement, because here meron kagad statement na x and y and z should be integers. So our domain for the second statement could be z cubed, or set of all triples of integers z cross z cross z, because again x is a variable, so it has its own candidates for its values. Y is another variable, z is another variable. So individually, these three variables might have different possible values. It just so happened in example B na pare-parehas yung pinanggagalingan nila, which is the set of all integers. Okay, and I think, yeah, for instance, here 140 belongs to, or the order triple 140 belongs to the domain, because x, y, and z, or the values of x, y, and z here are all integers. And if you plug in x, y, and z into this statement, we get a true proposition. But again, elements of the domain need not make the statement true. For instance, 1, 2, and 3 is a triple that belongs to the domain of statement B. However, since x plus y plus z will be equal to 1 plus 2 plus 3, which is 6, not equal to 5, so therefore, that element of the domain made the statement be false. Okay? All right, so let's, I think example 2 here is quite self-explanatory. So this is just, you have a proposition here, P, which where the domain of the variable x is the set of all real numbers, kasi specified na siya sa problem. And the statement here is that x squared is greater than x. So that's your predicate P. And then in order to check if P of 2, P of 1/2, and P of negative 1/2 is true or false, then you just need to plug in those values for the x in the predicate statement. Okay. All right. So the third part of a predicate, third statement of the propositions or type of propositions we're considering are what we call quantifiers. This will tell us how many elements of the domain are we claiming the predicate for. So there are two types of quantifier. We have the universal quantifier, and usually a universal quantifier could be the statement for every, or the phrase for every, for each, for all, and given any x. And as the name implies, if you have a universal quantifier, that means we are claiming the predicate to be true for all elements of the domain. Okay. Again, if we put a universal quantifier in front of a predicate, we are claiming that the predicate will be true for all elements of the domain. And usually, universally quantified predicates look like this. Okay. So let's look at the first one. So we have the symbol inverted A. That's read as for every or for all o kaya given any arbitrary something. So yun yung base sa inverted X. So here, for all X element of A, P of X. So since this statement is universally quantified, that means we are claiming that the statement P is true for all values of X belonging to the domain. Okay. Or you can just drop the for all, because it's understood in math that when you don't give any restrictions to your variable, that means it can take any arbitrary value. So if you're not comfortable writing the for all symbol, pwede mong isulat na lang siya ng ganito. X in A, P of X, means you are claiming that for every or given any value of X, as long as it belongs to the set A, then P of X will be true. Pero I will encourage you guys to make use of the for all symbol para ma-remove yung any ambiguity in any discussion or anything that you write. Okay? And I think the propositions that we considered before are basically universal in nature because they're yung mga statements na kinonsider natin, although wala silang subject part, pero ang assumption natin or nasa isip-isip natin in our intuition, we are claiming it true for all possible cases of the proposition. Okay? Pero ngayon, mas explicit tayo. So sinasabi na natin na yung P, totoo siya sa mga X's. Pero when we put a universal quantifier, we are saying it is true for all possible value of X. Okay. Now, some examples, illustration 3. So we have the predicate R of X that will stand for X being a real number, and Q of X will stand for the predicate X is a rational number. Okay. And then if your proposition looks like this, okay, if you want to say for every X, X is a real number, then you write this way. For all X, R of X. Because we already know what R of X stands for. R of X stands for X is a real number. So you read it as if you're just translating symbols into words. So you'll just say for all X, X is a real number. Or if you want to say X is not a real number for any given X, then you can say for all X, hindi totoo yung R of X. Or you can say the negation of R of X. So you can read this at for all X, it is not true that X is a real number. Okay, kasi yung negation, ganun yung basa natin, di ba? You can just replace it literally with the phrase, it is not the case. Or you can be fancier or more elegant than that. Just use the negation of the actual statement, just as like here. So for all X, X is not a real number. Okay? So our main goal now is to see kailan nagiging true ang isang universally quantified predicate or ang isang universally quantified proposition. So a universal statement which comes in this form, as we have seen, this will be true if it is true for any X in the domain. So kaya nga siya universally quantified. We are claiming the predicate P is true for all possible values of X. Okay? Belonging in the domain, of course. So kailangan isipin nyo rin, ano yung domain under consideration? Now, kung totoo siya, Pag sinubstitute ko lahat ng element ng domain dun sa predicate, then the statement will be true. But otherwise, if I can find even one, again, if I can find even one element of the domain for which the statement P of X is false, then the universally quantified predicate is false. Tapos ang tawag natin dun sa value na X na nagpa-false dun sa statement ay isang counterexample. And actually, giving a counterexample is enough, is sufficient, or is enough proof to say that the universally quantified statement is false. Kaya mabigat pagka meron kayong proposition and you used a universal quantifier in front of it. This is very important, or this is a very huge claim, because you're saying sa kahit anong value ni X na i-plug in ko dun sa proposition, as long as X belongs to the domain, laging true yung proposition ko. Okay? Kaya kung alam niyo na false yung proposition or yung predicated proposition, madali siyang i-disprove kasi kailangan niyo lang ng isang counterexample. Kasi nga ang ginamit na quantifier is a universal one. So it's easy to prove, it's easy to disprove a universally quantified statement because all you need is a counterexample. Meanwhile, medyo mahirap siyang i-prove. Kasi kailangan ipakita nyo na sa kahit anong element ng domain, lagi siyang totoo. And I guess we'll see some examples, at least for some finite domains. So kaya dapat clear kung ano yung domain na kinoconsider nyo. Let's look at example 5 here. Okay. Define yung domain to be the set A comprising of 1, 2, 3, 4, and 5. And we want to determine the truth or falsity of this universally quantified statement. For all x in A, so for every element of the domain, x is greater than or equal to 1 over x. So for us to check whether this statement, this quantified statement is true, i-check natin kasi universal siya. Totoo nga ba siya sa lahat ng elements ng domain? Luckily, our domain only has 5 elements, so it is easy to simply plug in those elements of the domain for all the subjects or all the variables we see in the statement. So you can start by doing, nandito na pala yung sagot. So you have 1 is greater than or equal to 1 over 1. 2 is greater than or equal to 1/2. You do the same thing until you have 5 greater than or equal to 1/5. So literally, pinlog in niya lang lahat ng elements ng domain dun sa proposition, dun sa predicate. Okay? Tapos nakita niya, oh, totoo naman lahat ng mga statements na yon. So therefore, this universally quantified statement is true. Kasi totoo siya sa lahat ng elements ng domain as claimed. Okay. Now, modifying the problem a little bit, let's go to example B. Pinalaki niyo yung domain. The domain now is a set of all real numbers and the same statement as in A. So we were asked to find a counterexample to show that this statement is false. So anyone can you give me a counterexample for example 5B? Come on guys, dapat pala may plus points no pag nagre-recite para ma-encourage kayo na sumagot. Okay. Mary has an example 1 over 57. That's great because 1 over 57 is not greater than or equal to 1 over 157, which is 57. Thank you, Mary. And I saw somebody else raised their hand earlier. Sino yung nagtaas ng kamay? Ayan, nahiya na siya. Sorry, hindi ko na-recognize. Kiefer also sent in an answer 1/2. Yeah, because 1/2 is not greater than or equal to 1 over 1/2, which is equal to 2. Okay, those are fine counterexamples. And again, since the statement is generic, the claim was generic. It was claiming for any real number, dapat x is greater than or equal to 1 over x. But your classmates gave me a bunch of counterexamples na hindi naman totoo yung statement. That means insofar as the domain, the set of real numbers, that statement would be false. Okay? Okay, siguro ganun yung gawin natin para meron namang benefit yung mga nagsasagot, no? Kapag ka nag-recite kayo either via the chat or via voice, so paki-take note. I'll give you I'll give you some points. Kailangan ko lang siyang i-normalize. Later ko nasasabihin kung ilang points. So pakitalin na lang, and then at the end of the meeting, kindly PM me kung naka-garner kayo ng points sa recitation. Okay? I'll add it to your problem sets. Alright. Okay ba yon, guys? Para lang may kausap ako dito, no? Actually, feeler ko yon. Pag gusto kong humigop ng kape, kailangan magtanong ako para meron akong chance to sip my coffee. Okay? So yan. Ngayon paunahan naman. So, alright. Anyway. Okay, so let's consider a more, let's see. I'm thinking exercise 6, but I guess exercise 6 is very similar to the illustration, to example 5. So I leave exercise 6 to you. Let's try example 7. Okay. Now here we have the predicates r of x. R is a real number, and x is a rational number. Okay. So here I think we are starting to translate statements into symbolic statements. So English statements into symbolic. So example A, all rational numbers are real numbers. Oh, basically this is translating universally quantified conditional statements into symbols. Okay, so let's try to dissect these examples. So first statement, all rational numbers are real numbers. So this statement, anong sinasabi niya? Intuitively, ang sinasabi niya ay lahat ng rational ay real. So at the back of our minds, parang ang ibig sabihin niya ay kapag ka pala siya ay rational number, automatic na siya ay real number din. Okay. And probably last week, tinatranslate lang natin to na Q implying P, right? Q implying R. Kung siya ay rational, automatic na siya ay real. Kasi that's the spirit of that's the thought of the statement. All rational numbers are real numbers, meaning if it's a rational number, then it is automatically a real number. So you can think of it as a conditional statement na kapag ka siya ay rational number, automatic siya ay real number. Okay? Now, we are looking at an inner or a more specific statement of the proposition. Okay, so you can think of it as for every x, if x is a rational number, then x is a real number. Okay, so parang yun yung expansion niya into a more precise predicated statement. Okay, now with that translation, we can write this proposition as a universally quantified statement because we are claiming that all rational numbers, ibig sabihin it should be true for all x's, okay? Na rational for all numbers x, okay? Kaya siya ay for all. Q of x, meaning if q is a rational number, then it follows that it is a real number. So kaya siguro this example will make you realize na parang ito ay mas specific lang na case nung last week nating ginawa. Okay? So, yeah, that's how you translate it. Pwedeng isipin niyo muna ano yung ibig sabihin talaga ng statement, and then it would be easier to write it in a more detailed fashion. And then once you have a more detailed statement equivalent to the given one, then you can more easily write it in symbolic form. Okay. So, pwede nyo ring observe yung pattern kasi later gagamitin natin to for more complicated statements. Okay? Okay, part B. No rational number is a real number. No rational number is a real number. So, isipin nyo. Ano yung ibig sabihin niya? No rational number is a real number. So that means kapag ka daw pala siya ay rational number, dapat hindi siya real number. Does that make sense? Sabi niya kasi walang rational number ang real number din. So statement B means kapag ka siya ay rational number, automatic na hindi siya real number. Kasi nga walang rational number na real number. So you will see here na hindi natin siya tina-translate literally. Sometimes in order to translate it easier, we want to look at the thought or the spirit of the statement. Okay? Again, no rational number is real number. We can interpret it as walang rational na real. So ibig sabihin, kapag ka rational siya, hindi siya dapat real number kasi nga walang rational na real. So if I want to translate it into a more detailed statement, I can say, meaning all real numbers are not, or all rational numbers are not real numbers. Or if it is a rational number, then it must not be a real number. And I guess that's an easier statement to translate symbolically. For all number x, if it is irrational, then it must not be a real number. So that's how we translate this statement. Okay? Any questions with that? I hope clear yon. Hindi kailangan literal yung pagkaka-translate. You can dig deeper, analyze the statement, write it in a more detailed fashion, and then maybe it would be easier to translate it into symbols. So perhaps dito I will suggest maybe we can say na if it is a rational number, then it cannot be a real number. Perhaps this is a better translation of the original statement into a more detailed one na mas madali siyang i-convert into this symbolic statement. Okay? Any questions? I hope this is clear because this is the crucial part when we try to symbolize statements. Kasi after nito, magpo-prove na kayo ng validity and so on. So crucial talaga yung first step, that you translate it properly. Okay? No questions so far? All good?
Clear naman po, sir.
Okay, thank you. Okay, let's try this one. Translate the following into symbols using predicates in the preceding examples. So, is the statement true? Every real number is not a rational number. So, can somebody tell me any volunteer? Aside dun sa mga nakasagot na kanina dun sa mga may plus points na. Who wants to translate it into symbols? Ang gamit nating predicates ay R of x, x is a real number. Tapos si Q of x, x is a rational number. Okay, now I see Alisa suggesting for all, I guess you have a for all x there, R of x is not Q of x. Let's analyze. So let's see. And then Charles said it's false. So let's see. Let's look at the statement. Every real number is not a rational number. So lahat ng real number ay hindi rational number, meaning kung siya ay real number, then it follows that it is not a rational number. So that means for all x under consideration, for all x element of the domain, R of x implies not Q of x. So I think Alisa is correct in her suggestion. Okay, so thank you, Alisa. Take note, meron ka ng bonus points. Kukumputin ko pa later kung ilan. And then Charles said this is false. Why is it false? Charles, can you give me your counterexample? Bakit mo nasabi na false siya?
Hello po, sir.
Okay, Mary Rose said it's true. Pero go ahead, Charles. Bakit mo nasabing false siya?
Kasi sir, if you would draw, ano po, how do I say this? A diagram po, kunyari, all real numbers is one big circle. Makikita mo po ang rational number sa loob ng circle po na yan.
Something like this.
Yes
Okay.
po. Yeah, something like that po, sir. Yes.
Tapos, makakuha ka ba ng real na hindi rational? Oh yeah, yung mga nandito sa labas. Tama?
Yeah. Yes po, sir.
Yeah, but do you want to be more specific about it? Can you give me a counterexample? Real number na hindi rational. Maybe I can ask Mary for that. Thank you, Charles.
Ano, sir? Exponential? Transcendental?
The transcendental exponential base. Okay, you're referring to E. So
Yes,
si E ay real number, pero hindi siya rational. Pero hindi ba siya magpapa-true dun sa statement? Kasi ang statement is any real number is not a rational number. So if you want to prove that this is false, you should give me a value of x that will make this conditional statement false. So kailan ba nagiging false ang conditional? Nagiging false ang conditional kapag meron kang true, implying false. So try ko nga i-analyze ulit yung kay Charles. Yung suggestion ni Charles. Si E ay real. So that means this is true. Okay? All right, that's good. Pero si E ba ay hindi rational? I guess siya ay not rational. So ibig sabihin, si E ay irrational. So hindi talaga siya rational. So true implying true. So mukhang may problema yung counterexample mo, Charles. I guess, si Charles may isa pa sagot 1/2. Okay, so 1/2, maybe I can call Mary. But I think your counterexample now is, okay, Mary, go ahead.
Sorry po, sino po yung Mary?
Sir.
Oh, sorry, come again, please.
Sir, dalawa po kaming Mary.
Okay, sorry. Sino yung nagtaas ng kamay?
Ako po.
Okay, go ahead, Mary Rose. Yeah. Sorry, dalawa pala yung Mary.
Sir, for this statement po, I think it's true. Kasi po, there are real numbers that are not rational numbers po.
Yeah. Oh, but you need to be careful. The quantifier here is for all. So, ibig sabihin sa lahat ng x, dapat kung siya ay real number, hindi siya dapat rational. So, yeah, yun yung problema. When you mentioned your argument na meron kasing mga real na hindi rational, okay, that's fine, that's true. Meron mga real na hindi talaga rational. Pero magkakatalo tayo dun sa quantifier. Ang quantifier ko kasi dito ay for all. So, yeah, maybe I think the other Mary Mitzi, I think you raised your hand earlier. You want to say something? Okay.
For example po is number 2. Real number po siya. And rational din po siya. And that would make the statement false po. Thus, ayun, false na po siya. Kasi may isa na pong counterexample.
Okay, thank you, Mary. I think that works because ang counterexample ni Mary ay 2. Okay? So si 2 ay real number. So that means the antecedent is true. Okay? Pero si 2 ay rational. So that means that makes the antecedent or the consequent false. Kasi real number siya, pero rational siya. So that makes not Q false. So you have true implying false, that makes the conditional statement false. So yeah, I guess this is, Charles is correct earlier in saying that this is false, but I guess Mary gave the the right counterexample. Okay? So I hope that's clear. But I like the discussion. So lahat ng mga nakiparticipate, take note, you have some points. PM niyo ako mamaya para matali ko siya. Okay? So, yeah. Now, ganun ka-generic yung statement or napaka-bigat ng universal quantifier. And sometimes we don't want to claim that that is true. So we have another kind of quantifier, and maybe this is what Mary Rose is referring to earlier. This is an existential quantifier, which will just limit the claim of the predicate to some elements of the domain. So our existential quantifier usually is indicated by the terms for some, or there exists, or for at least one x. So yun yung mga keywords for the existential quantifier. The symbol is a mirrored E. Ang base sa kanya, usually binabasa ko siya na there exists, pero pwede nyo siyang basahin na for some, for at least one x. Pero ang thought niya ay kiniklaim ko lang yung predicate na P para sa ilang elements ng domain. So there is at least one element of the domain such that the statement P is true. Okay? So in contrast to universal, sa universal totoo siya dapat sa lahat. Pero itong existential dapat totoo lang siya sa at least isang element ng domain. So for instance, if we look at example 9, we have two predicates. P of x is divisible by 3, kaya capital T yung ginamit. First letter ni 3. And S of x is divisible by 6, kaya S, first letter ni 6. So sana ganito yung gawin yung mga variables pag nag-ano kayo, yung madaling i-associate dun sa statement to be statement being represented, para intuitive din pag nag-check, lalo na pag maraming involved, mahirap i-keep track. Ano nga ba si A? Ano nga ba si B? It would be better if you can attach some meaning to the variables. But pero request lang naman yun. Pero once you have this declaration, then that's fine. Kung may declaration ka, okay lang yun. Pero mas maganda kung yung variables na ginamit ay medyo related dun sa statement being represented. Okay? Now, when you say for some x is divisible by 3, we can say there exists an x such that P of x is true. So meaning we are claiming the existence of at least one number that is divisible by 3. Hindi ko sinasabi na lahat ng number ay divisible by 3. I am just claiming when I use the existential quantifier that there will exist an element of the domain such that the statement T will be true. Okay. Or if you have statement P here, for some x is not divisible by 3. So in symbols, there exists an x such that not T. Or there is some x in the domain such that it is not the case that T is true. Oh yes, Carlo, you have a question?
Just a question. If the domain is not mentioned, like there's no element of real here, is it assumed that the domain is the real?
Oh, good question, yeah, Carlo. I think sasabihin mamaya dun sa work text or sinabi na above. I just forgot to mention, yeah. Kung walang na-specify na domain, you can think of the more generic domain. Or pwede nung i-assume na ito yung pinakamalaking posibleng domain. So for instance, you're right. If you're looking at example 9, so the domain could be treated to be the set of all real numbers. Or you can be even more specific about it. You can just say a set of all integers. Kasi yung divisibility, defined lang naman siya sa mga integers. Or sa mga kahit nga sa natural numbers lang. So yeah, whenever the domain is omitted, you can take it to be the largest possible set for which the predicates will make sense. Though in practice, pagka hindi sinulat yung domain, it means that the domain is not that significant insofar as the problem is concerned. Pero yeah, but whenever the domain is of importance, we will define it explicitly. Okay, lalo na sa mga examples or problem sets. Pero pag hindi siya sinulat, ibig sabihin in context dapat clear kung ano yung domain. But yeah, that's a gray area, and we'll try to be as specific as possible when we talk about these statements. Okay. Yeah, but thank you for bringing the top. Okay. Now let me just finish probably in 5 minutes. Overtime muli ako ng 5 minutes if you would allow me. If you have classes, you can go. You are dismissed 10 minutes before the end. You can just watch the last 5 minutes of the recording. But I just want to end with a test for the truthfulness or falsity of an existential statement. So when you have an existential statement, kiniklaim niya lang yung statement to be true for at least one element of the domain. Okay, so that means it is sufficient to find at least one example of an element of the domain that satisfies the predicate for the existentially quantified statement to be true. Meaning kung meron kang statement na there exists an x in A such that P of x, ibig sabihin pag nakapagbigay ka sa akin ng isang element ng domain for which the proposition P of x is true, then that is sufficient proof. Kasi napaka-specific ng existential quantifier. Meron lang at least isa kung saan totoo yung P of x. So pag binigyan mo ako ng isa na totoo si P, ibig sabihin okay na ako, na-prove ko na yung statement. Okay? The harder part is to disprove an existential statement. Okay? Kasi para ma-disprove ang isang existential statement, you need to show na walang element ni X na totoo si P of X. Or in other words, you should be able to show that P of X is false for every element of X. And proving a universally quantified statement is hard kasi kailangan i-exhaust mo lahat ng posibleng cases dun sa domain. Or use logical arguments in order to prove the impossibility of P of X to be true. Okay, so let's see. Example 11. So here the domain is the set of all integers. So let's see. Let's look at the statement there exists an M in A such that the root of M is equal to M. So ang claim lang ng statement, merong isang integer ng square root niya ay equal sa sarili niya. And that is easy because can somebody give me the proof for this? Can you give me an example for which this statement will be true? Okay, dalawang Mary, may points sa kayo. Is that cheeky? Ayan, dinagsana ako sa chat. Okay, 1, 1, 1, 1, 1. Okay, great. Cut off na ako kay Aldrich. I think cheesy. I don't know, cheeky or cheesy also tried to answer. Okay, the answer is, yeah, your examples are correct. M equals 1. Is there another one except for 1? Meron pa ba? Wala na, no? Oh, 0. Great, Daniel, that's correct. 0 is also true. Square root of 0 is equal to 0. So, yeah. Pero hindi ko kailangan ng marami. Kailangan ko lang ng may existence. So, ibig sabihin, pag may isa akong napakita, sufficient proof na yon kasi napaka-conservative nung statement ko. Merong isa, may at least isa. Actually, you gave me 2. Meron pa ba aside from them? Parang wala na, no? 0 and 1 lang yung totoo. So, okay. So, that's enough to prove negative 1. Hindi na pwede negative 1, Mary. Kasi ang square root ng negative 1 would be imaginary number I. Tama? And I is not equal to negative 1. But nice try though. Okay. And our domain is the set of all integers lang. So disqualified na. Pwede pala si negative 1 pero yeah. Square root lang, hindi cube root. Okay. All right. So okay. However, if we limit our domain, if we say the domain is the set 2, 3, 4, 5, and we'll consider the same statement, this is false. because I can check, okay? I can check kung totoo nga ba siya sa about isang element on the domain. Root 2 definitely is not equal to 2. Root 3 is not equal to 3. Root 4 is equal to 2, not equal to 4. Root 5 is not equal to 5. So hindi siya totoo sa kahit na anong element ng domain. So that means walang nag-exist na element ni domain na totoo yung statement. So that means the existentially quantified proposition is not true whenever the domain is a set 2, 3, 4, and 5. Actually, any number set, not including 0 and 1, will make the existentially quantified statement false. Kasi sila lang yung posibleng makasatisfy ng statement. Okay? So I guess I'll call it a day there. Thank you, everyone. I love this this meeting better kasi ngayon nagpa-participate na kayo. Kailangan lang pala ng plus points, no? So those who answered today, just baka pala dagsayin ako ng chat, no? Dito sa meeting chat, pwedeng pakilagay kung sumagot kayo or hindi. Aside from dun sa mga nagsagot via chat, yung mga nag-recite, please indicate na you recited by verbally. So pakilagay na lang dun sa chat para doon ko na lang babasahin. Wag na palang PM kasi dadagsayin ako ng PM. Okay? So pakilagay dun sa meeting chat natin later. Yung mga sumagot via chat, bibilangin ko na lang yung sagot nyo. Babalikan ko mamaya. Okay? Now, before we end, it doesn't matter if your answer is right or wrong. All I'm after is the participation. So, kahit mali yung sagot nyo, lagay nyo lang. Pero, yeah. So, what was I about to say? Di ba meron tayong problem set 1.1? Di nyo pinapansin yung Ben and Ben meme ko dun sa Canvas. So, anyway, or you find it corny. So, respeto naman guys, magpanggap naman kayong nasayahan kayo. Hindi, joke lang. Yeah, di ba meron tayong problem set 1.1? Kailangan nyo maghanap ng meme. Ngayon, dahil natutunan natin yung universally quantified statements, you can also choose your argument to be universally quantified. Lalo na yung mga kasi usually, dito nangyayari yung usual fallacies eh. Magsasabi siya, for all naisip ko politically charged statement, pero bawal tayo mag-politics dito. Basta, meron ka makikitang claim that is true for everyone. So, tapos yun yung gagamitin lang argument. But you can easily find a counterexample to their claim, so invalid na kagad yung argument. So you can take your time. The deadline is October 27th. If you want to find, if you have a nice meme which involves universal quantifiers, it's good. Pwedeng antayin nyo makaabot tayo dun sa proof of validity of quantified statements before you submit your problem set 1.1. That's fine. So pero pwede nyo siyang gamitin dun sa XR 1.1. Okay? And then, what else? Oh, I think that's it from me for today. Hindi naman strictly memes. Pwedeng video clip, pwedeng audio clip na napakinggan yung podcast or anything. Meron kayong nakitang nag-post sa Facebook ng something. Blur nyo lang yung pangalan, data privacy something. So, anything in media. Oh yes, Mary Rose, you have a question?
Sir, paano po pala yung i-attach na file if ever na yung ginamit ko po na statement is from a book?
Kung from a book, pwedeng picture na lang. Or pwedeng kopyahin mo na lang, i-type mo or isulat mo na lang dun sa PDF mo. So, okay lang.
Total plot po nung book yung...
Total plot nung book. Okay. Summarize mo na lang.
Sige po.
So, summarize mo ng English para makita ko yung translation. Kasi 3 parts yung hanapin ko sa submission nyo. Number 1 is yung English statement na paano nyo yung English statement. Second part is how you translated it symbolically. And then third ay yung proof nyo ng validity or invalidity. So, yeah. So, yun yung tatlong parts. So, kung masyado siyang mahaba, summarize nyo na lang. Sophia?
Yes po, sir. Halimbawa po kasi yung kukunin ko like Facebook comment. Ang dami-dami niya pong sinabi pero sa palagay ko lang naman kaya ko siyang magawa into two premises. Okay lang po yun.
Okay lang.
Cut short ko. Okay po.
Okay,
Thank
so
you.
hindi naman kailangan literal yung pagkaka-translate. So pwedeng merong mahabang statement, tapos feeling nyo ito lang yung gist ng kanyang argument. So pwede nyo ilagay in a so i-attach nyo yung actual statement, tapos ilagay nyo sa baba, mag-note kayo na, in my opinion, the statement can be summarized as follows, na English. Okay? Tapos, after nung summary nyo na English, saka nyo i-translate into symbols. Para makita ko lang ano exactly yung tin-translate nyo. Para alam ko na hindi nyo tinry i-translate yung napakahabang statements na yung iba naman ay gibberish or hindi related dun sa conclusion. Okay, that's also fine. Okay, so you can be as creative as you want in that homework. Though I will grade it technical, pero hindi naman ganun ka strict. Okay. Okay, any other questions? Okay, if none, I had fun, guys. Hopefully ganito tayo every lecture. So, I hope you enjoyed the rest of the day, and then let's see each other again on Thursday. Bye, everyone.
Thank you po. Stay safe.
Thank you po.
Thank you po, sir.